they also have some interesting properties against adversarial images, which are just misclassified images. So since it has this ranking property, it will still classify them correctly, even if they have been mislabeled. Yeah. Okay. So yeah, and yeah, well, this is the abating probability. So they argue that it provides an open set recognition function, so that they say this is the solution for open set, and they provide a very short proof for the theorem, which is basically that these are all real probabilities as opposed to softmax, which are artificially created probabilities. The argument is these are probabilities, so this is giving you an open set model as well as a classification output.
Isn't also the fact that they use the distance, so it means that outside like of a ball around the activation function of that class, then it becomes 0? Right?
Yeah, so that's the abating probability.
Yeah.
So the abating property. So it also says that the probabilities will go down as the examples are farther from your mean activation vector.
So what is the abating property? Because I didn't understand that.
Is that the probability of something being in the set will go towards 0 as this activation is further from the mean value. So if that is not true, you're not properly modeling the open set, because if something very far from the mean can suddenly have high probability, then it doesn't work out. But then they argue that because of the way they constructed it,
could you argue is the real probability if you have a choice of alpha, which is arbitrary, for instance, so you can have several sets of probabilities. Not everyone can be the right one.
So yes, if you pick all the alphas, you are modeling the probabilities for all the classes.
What I mean is, maybe I misunderstood. I thought you meant that their method is the way of calculating the right probabilities.
Yes, they say it's an open set recognition function. So there are in that paper they define what is an open set recognition function, and one of the properties that it needs is that for a given class, the farther an example is from the mean value, then the probability of it being an outlier has to increase, or the probability of it being in the classes has to go towards 0 monotonically, so it cannot.
And this definition is from them as well. It's not a standard. Is it something which is widely accepted, or is it kind of had a view?
Well, I mean that's just what everyone is trying to solve in the open set problem. So these are the properties of the open set. Okay. So yeah, I think that the last image there is just to show that indeed they do better than softmax all the time. So when they calculate the F-score, so this F-score, it's calculated also taking into account the missed rejections. Okay, so softmax does worse at rejecting stuff, so the F-score is lower than the OpenMax all the time, regardless of the threshold. So that is an interesting property as well. Yes?
So based on my human analysis and non-expert reading of this paper, I noticed an outlier in the references, which was number 18. And I was just wondering if I could flag it because it struck me as odd to see it in the context of this.
No. Ah, yeah.
So I'm wondering if that theory is licensed.
It's not really. That is a. Well, that is just a very famous quote that this guy made. He was defense secretary for the U.S.
Yeah, he talks about. It's a quote about war.
Yes, and he said that in the war against terrorism there are known unknowns and unknown unknowns, and that he received a lot of heat because so the U.S. has unknown unknowns in the war against terrorism. So it's just. I think it's just because he's using the same terminology.
Was he the first to use this? Like this is logic, right?
I don't know if he's the first to use this, but yeah, I think this is more like a nod rather than a proper reference.
It's not like a
So it's,
Yes.
it sounds like you should always use this rather than softmax. So why does everyone use softmax?
That's a good question. Because so all these things they're always faulty, right? They provide open set recognition, but of course you're also taking away probability from the outputs that you actually want to recognize. So if you are certain that you're not going to encounter an open set problem, then you do not need this. If you do not need to do open set recognition, which is accurate for many machine learning applications, like you know what it is you're going to encounter out there. And if you're not really concerned with the open set problem, then you don't have
I think it's just
Open set just means that there will be unknowns.
that there will be unknowns.
Yeah. But that sounds like it's more robust, right? So even if you don't have any unknowns, like, what's the downside, I guess, is what I don't understand.
Well, the downside is that first you have to calculate the Weibull distribution. So if you have a lot of data, you may not be able to fit a distribution for all of your classes.
Yeah.
Maybe it's too computationally expensive. Then you can be creating an unnecessary unknown class.
Right, yeah.
Then this process is going to be slower than softmax because your layer has to calculate that exponential. You have to fit it to all of the means. So this is not just with one mean, but you have to calculate the distance to every mean.
Yeah.
So yeah, it's going to be slower than softmax. So if you're not really facing the open set problem, it doesn't make sense to implement this.
So the unknown.
Depends on your system.